Picture this: a world where ice doesn't float. Winter comes, and lakes freeze from the bottom up, turning into solid blocks of ice. Fish have nowhere to go, plants can't survive, and entire ecosystems collapse. The oceans, instead of having floating icebergs, become icy graves, trapping cold deep below. It sounds like a disaster movie, but thankfully, that's not our reality. In our world, ice floats, and that simple fact is the reason life thrives even in freezing temperatures. But why? What makes ice so special that it breaks the usual rules of sinking? The answer is all about density, how tightly packed the molecules are in a substance. Normally, when things get colder, they shrink. Their molecules slow down and huddle closer together, making the solid version denser than the liquid. That's why a lump of solid wax sinks in melted wax, or why most metals become more compact when they freeze. But water, it's different. When water turns to ice, it expands, becoming less dense than the liquid water around it. That's why ice cubes float in your glass and why icebergs drift instead of sinking to the ocean floor. To understand why this happens, we need to look at water's molecular structure. A water molecule is made of two hydrogen atoms bonded to one oxygen atom. In liquid water, these molecules move around freely, sliding past each other like dancers in a crowded room. But when the temperature drops below freezing, something unusual happens. The molecules arrange themselves into a rigid, hexagonal pattern, like a honeycomb. This structure creates tiny gaps between the molecules, making ice take up more space than the same amount of liquid water. In other words, ice is lighter for its size, which is why it floats. Think of it like a box of marbles. If you pour them into a container, they'll settle into a tight, dense pile. But if you arrange them in a precise grid with gaps between them, the same number of marbles now take up more space. That's exactly what happens when water freezes. The molecules spread out, making ice less dense than the liquid water beneath it. This strange behavior has huge consequences for life on Earth. If ice sank, bodies of water would freeze solid in winter, killing fish, plants, and microorganisms. Instead, ice forms a floating insulating layer, keeping the water below at a stable temperature where life can survive. This is why, even in the coldest winters, lakes and rivers don't freeze completely. There's always liquid water beneath the ice, sheltering the creatures that live there. The water's weirdness doesn't stop there. Unlike most substances, water reaches its maximum density at 4 degrees Celsius 39 degrees Fahrenheit, not at its freezing point. As it cools further, it expands slightly before turning to ice. This is why water pipes can burst in winter. The ice inside takes up more space, cracking the pipes. It's also why ice cubes bulge at the top when they freeze in a tray. This unique property of water is one of the reasons life exists as we know it. Without it, Earth's climate would be completely different. Ocean currents, which rely on temperature and density differences, would change dramatically. The insulating layer of ice on polar seas protects marine life and helps regulate the planet's temperature. Even the simple act of ice floating in your drink is a reminder of how perfectly suited water is for sustaining life. So the next time you see ice floating in a glass, remember it's not just a quirk of nature. It's a vital feature that keeps our world alive. And if that doesn't make you appreciate the science behind everyday things, what will?
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.